Hello everyone and welcome to Diksha Karnataka YouTube channel. In the midterm series, it is time for me to discuss all the important 2-3 marker questions from the chapter Electric Charges and Field. I have already discussed a brief theory revision as well as all the important MCQs from this chapter. Now it's time for me to discuss all the important 2, 3 and 5 marker questions that will come from this chapter definitely. So if you want to score well in your midterm, definitely you have to check this video till the end. And before I start, just want to discuss how many questions I am going to discuss from this chapter. So 1 to 6, all the questions are 2 markers. So total 6 questions will be 2 marker question. Total 5 questions will be 3 marker question. We will also discuss 4 derivations and 5 numericals, right? So this is the number of questions. Total 20 questions we are going to discuss from this chapter. If you watch these 20 questions, all the questions that will come from this chapter, you will be definitely able to answer all the questions. Now let us start with the first question. Write Coulomb's law in vector form, explain the terms, state and explain Coulomb's law. So either it will come as state Coulomb's law in vector form or it will come as state and explain Coulomb's law. Both questions are same, only difference is that the statement part will be same. Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to product of magnitude of the 2 charges and inversely proportional to the square of the distance between them. Coulomb's law in vector form can be written as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square R vector. So if they ask you statement, you have to write the statement. If they just ask you to Coulomb's law in vector form, you can start from this equation directly. But this equation is incomplete without a accompanying diagram. This is the simplest possible diagram that you have to draw. There are other diagrams as well. One of them is given in your textbook, but this is the simplest possible diagram that you can draw here. Okay. Now here you have to mention the terms. So Q1, Q2 are point charges, epsilon naught is the permittivity of free space, R is the distance between Q1 and Q2, R cap is the unit vector. Now in vector form there is a possibility that you have to write F12 is equal to A minus F21, but in general that is not required. If you are interested, you can write that as well, that is given in your textbook, but this is fine as long as you are writing this equation and drawing this diagram, you will perfectly fine, you will score the full marks. Now let's move on to the next question. Sketch the electric field lines for electric force, field lines of force due to a point charge Q if Q is less than 0. So what is the meaning of Q less than 0? That means Q is negative, right? And Q greater than 0, that means Q is positive. So either a negative charge or a positive charge. How does the electric field lines looks like? So this is the diagram for negative charge, this is the diagram for positive charge. Simple diagram, and if you draw it, you can score 2 marks. Right. Next question, state and explain Gauss's law in electrostatics. Common question. Gauss's law states that the total electric flux passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. Explanation is phi equals to Q by epsilon naught. Now phi is given by E dot ds close integral, and that will also be equals to Q by epsilon naught. Here you have to mention Q is the total charge enclosed by the surface. If you can draw a surface and some charge inside it, that will be perfect and you can score full marks. The same statement you might be able to write in case this is comes as a 1 marker question in a 5 marker derivation. There are few questions where they will ask you state Gauss's law and hence explain or derive this equation. Right, in that case this statement you have to write it. The mathematical explanation is not required, but the statement you have to write if this question comes as a part of a 5 marker derivation. So be careful, that is also possible, that also has come in the past. It might come in one of your midterm or in the annual exam as well. Define electric dipole moment, mention its SI units. So electric dipole is a pair of equal and opposite charges q and minus q separated by some distance 2a. Its dipole moment vector p has a magnitude 2qa and is in the direction of the dipole axis from negative to positive. Okay, so dipole moment is from negative to positive, and its dipole moment magnitude wise it is given as multiplier of any one of the charges times the distance between the dipole. Its SI unit is Coulomb meter. Very important, its SI unit is Coulomb meter, and its dimension is, what is the dimension of Coulomb? AT, and meter is L, so it will be LTA. Okay, this is the dimension of dipole moment. Sometimes it is also may come handy. The charges are additive in nature, explain. So this is also the property of charge, and sometimes one of such property might be coming as a explanation question, 2-marker explanation question. So be prepared for that as well. If a system contains 2 point charges q1 and q2, the total charge of the system is obtained simply by adding them algebraically q1 plus q2. So if there are 2 charges, I will give you some example as well. If there are 2 charges q1 and q2, you can simply add them algebraically. That means it's a scalar quantity. Charges add up like real numbers, or they are scalars like the mass of a body. So charges are basically scalar quantity. For example, if you add 1 kg with another 1 kg, you get 2 kg, right? The difference is that mass is always positive, charge can be negative as well. That is the basic difference. So total charge of a system containing 5 charges, say +1, +2, -3, +4 and -5 in some unit is +1 +2 +-3 ++4 +-5 equals to -1 in the same unit. Okay, you can mention Coulomb also, that is not an issue. The example is directly taken from your NCERT textbook, but this is one of the very common and easy to understand explanation. You don't need to remember this example. You can have any charge of your understanding. If you understand this, you can write it on using your own words, using your own numbers as well. Now the force between 2 point charges is F. What is the new force when the distance between them is halved? Okay, so what will be the new force if the distance between them is halved? So we know that force between 2 charges is directly inversely proportional to the square of the distance, right? Force is inversely proportional to the square of the distance, right? Now what will be the new force? Suppose this is the old force, and the new force F dash, it is also proportional, so it will be 1 by r by 2. Distance is halved. Halved means, sometimes student confuse, halved means basically the distance is 1 by 2. Okay, you have to multiply the distance with 1 by 2 or divide it by 2. Halved. Double means multiply by 2, triple means multiply by 3, quadruple means multiplied by 4, right? So distance is halved. Now what will be the force? F dash by F. You have to find the ratio first. So F dash means r by 2 will be in the denominator, because F dash means r by 2 in the denominator. Cross relationship for F, it is again cross relationship for F in the denominator. That means it will be like this. So what is the relation? So F dash by F equals to 4r square by r square, cancel. So F dash will be 4F. So force will be quadrupled. Force will be quadrupled or 4 times. Okay, force will be quadrupled or 4 times, whatever you are comfortable with. Now next question, derive the expression for the torque on an electric dipole placed in an uniform electric field. So we have an uniform electric field. okay, and we have a dipole placed here. So we know that if the dipole is placed say at an angle theta, it will experience a force, right? Try to draw the lines using a scale so that they appear to be parallel, okay. I am drawing using my hand, so it may not be perfectly parallel, but if you can use a scale and draw them perfectly parallel, that will be good, right? Now, so electric field has a value say E, okay. Dipole, this is say plus Q, this is say minus Q, okay. Now what will happen to the dipole? So the plus Q charge will experience a force in the direction of the electric field, right? Plus charge always experiences a force in the direction of the electric field. Negative charges experiences a force in the opposite direction of the electric field, so it will experience a force in the opposite direction. Now what is the magnitude of this force? Magnitude of this force is given by Q times E. Electric force is Q into E, and if you see that the magnitude of the force in the negative charge will also be the same value. So plus QE in this direction, minus QE is in this direction. That means the force acting on the both charges are equal in magnitude. Now two equal and opposite forces acting on an object, okay, that means it will experience a torque. Now what is the definition of torque? Torque is given by magnitude of any one of the forces times the distance between the forces. The distance between the forces. So you have to find the distance between these two forces. If they are acting on a same object, suppose we have only one object, if the force is acting on the same object, the distance between the forces is 0, so torque is 0. But in this case they are not acting on the same object, but they are acting on same object but not at the same point, at different points, okay. One is acting over here, another is acting over here, right? Now what is the distance between the dipole? Distance between the dipole is generally represented by 2a, right? You can, in this case you can take x as well, no problem, but as we are always using 2a, we will use that value only. So distance between the forces is this one, okay. So what is this value? We have to find that. Now we said that the dipole makes an angle theta with the electric field. Dipole makes an angle theta with the electric field means this angle will also be theta. This angle will also be theta. Now you have to use the triangle. So if you see that this is a right angle and this is the hypotenuse, okay, this is the hypotenuse 2a, this is the right angle, so and this will be the perpendicular. Why? This is the angle, and if you see that this side is not adjacent to this angle, that means this will be perpendicular. Any side which is adjacent is called base. Any side which is adjacent is called base, and which is not adjacent is called perpendicular. Let me just give me one moment to rewrite that so that there is no confusion, okay. Now so what you have to do, you have to find this distance of this height of this perpendicular. So we know that if you remember the mnemonics, some people have curly brown hair turned permanently black. So some people have, so that means sin theta equals to perpendicular by hypotenuse. What we are trying to find? We are trying to find the perpendicular. What is given to us? The theta and h are given to us. So we can write P equals to h sin theta. What is the value of h over here? H is hypotenuse, that is 2a. So 2a sin theta is the perpendicular. So we have to, so this is basically the distance. This is the distance. Let me write it here as d because I said this is d, right? So this is d. So the value of d is 2a sin theta. Let me put that in the equation. So tau is equal to f into 2a sin theta. Now what is F? F value we have already calculated, it is Q into E. So Q into E 2a sin theta. Now if you see that what I have done here, the diagram is compulsory. 50% of the declaration I have done itself in the diagram. Remaining declaration I am doing in the derivation. So because this is a 3 marker question, I do not need to declare everything in detail, but if you use your diagram wisely, okay, declare some of the variables in the diagram itself and then do the calculation like this, it will be sufficient for you to score full marks, right? So E into Q into 2a sin theta. Now what is Q into 2a? Q into 2a is called the dipole moment. So we will write this as P into E sin theta. So what is P? P is Q into 2a equals to dipole moment. So you have to mention everything. Whatever I am doing is the minimum possible derivation for this question. Now if you see that P is sin theta, this is the basic derivation, okay, but not completed. If you want to score out in future, you will get full marks for doing P sin theta, but if you want to score out, then I will suggest you to write this in vector form, P cross E. Okay, this is the vector form. You have to write in vector form. Why it is important? The detail matters. When you are trying to score out, the teacher has to know that you are actually a good student. Okay, so in case even if you make small mistakes in future in some other question, the teacher will realize that is not a forced mistake. It may be just a minor negligence from your side. So you might consider and you might get a full marks even if you make small mistake in future. That's why I always say that your exam paper is the mirror for the teacher. The teacher will see you through the exam paper that you write. Okay, so writing the exam paper properly is very, very important, and teachers do keep an eye for detail, and they realize that this is a good student's paper, so I will be more careful and I will try to give as much marks as possible to the student so that he can score well in the exam. So that is how you can reflect yourself to the teacher who may know you, may not know you. So that's why it is very, very important. Now write any 3 properties of electric charge. So we have to find the properties of electric charge. What are the properties? Very easy question. Additivity of charges. Charges are additive in nature. Quantization of charges. All charges are integer multiple of smallest charge, small e. Conservation of charges. Total charge in an isolated system is conserved. Total charge in an isolated system is conserved. You can write that charge is a scalar quantity. Okay, that is also fine for the explanation of additivity of charges. Okay, whenever you write the properties, write one line, at least one line description. They are not expecting you to write a full history over here, but at least one line explanation is sufficient for you to let the teacher know that you have studied it. Okay, because I have seen students, additivity of charges, quantization of charges, conservation of charges. What is the meaning of that? Okay, and teachers sometimes get really angry and they might deduct some marks in future if you make small mistakes. There are no scope of deducting marks over here, but teacher will realize that you have just memorized the answers without understanding and you are writing it. So that, as I said, the exam paper that you write is the mirror for the teacher. They can see you through that mirror. What is an electric dipole? Define electric dipole moment, give its direction. So dipole, two equal and opposite charges separated by a small distance is known as electric dipole. So two equal and opposite charges separated by a small distance. So Q minus Q, distance 2a. Okay, dipole moment. Electric dipole moment is the product of the magnitude of one of the charges and the distance between them. It is a vector quantity. The direction of dipole moment is from negative to positive charge. Next question, write 3 properties of electric field lines. Very important, very important question, and in midterm exam I have seen teachers sometimes give this question as a 5 marker question. Trust me, I have seen that. Okay, so it might come as a 3 marker question. There is a 1% chance that it might come as a 5 marker question. So try to remember 5 points from this properties. Okay, so that you can write, if teacher gives you a easy question and give this as a 5 marker question, but you will say, sir, I have prepared this for 3 marker, I don't know other 2 points, so what to do? So you have to memorize at least 5 points of that. I will not say memorize, I will say that you have to understand 5 points. So even if you forget, you can write them in your own words. So electric field lines may start from positive charge and end at negative charge. Easy point to remember. Now they are not 2 separate points, this is a 1 point. So I have seen students writing electric field lines may start from positive charge, end at negative charge. Okay, and the next point they are writing electric field lines end at negative charge. That is not true. You have to write it as a single point. In charge-free region, electric field lines can be taken to be continuous curves without any breaks. 2 electric field lines never intersect each other. Easy point. Electrostatic field lines do not form any closed loop. Electric field in free space decreases as we move in the direction of the electric field lines and vice versa. Okay, so if you are moving in the direction of electric field lines, electric magnitude decreases. If you move in the opposite direction of electric field line, the magnitude increases. 2 point charges. Now this is a 3 marker numerical. 3 marker numerical is well possible. 2 point charges, QA is equal to 3 microcoulomb and QB equals to minus 3 microcoulomb are located 20 centimeter apart in vacuum. What is the electric field at the midpoint O of the line AB joining the 2 charges? So here we have 2 charges, A and B. Okay, 3 microcoulomb minus 3 microcoulomb. Okay, they are located 20 centimeter apart. So 20 centimeter is the distance between them. What is the electric field at midpoint O of the line AB joining the 2 charges? So what is the electric field at the line joining the 2 charges? Okay, so you have to find the electric field at the midpoint. So what is the distance of the midpoint from this charge? So total distance is 20 centimeter. That means this will be 10 centimeter. This will be also 10 centimeter. Okay, now what is the electric field due to positive charge? Electric field due to positive charge will be in this direction. So this is EA. Okay, what will be the electric field due to the negative charge? Electric field due to the negative charge will be in the same direction and it will be EB. Why so? Because electric field due to positive charge is away from, whereas electric field due to negative charge is towards. So both the electric fields are in the same direction. So you have to add them. So let us first find the electric field due to positive charge. What is the formula? K Q by R square. Simple formula. What is the value of K? K is 9 into 10 to the power of 9. Now you have to practice more. Okay, numericals, practice more. Once you are done with this lecture, you can go and check the numericals given in the NCERT textbook. End of the exercise, practice them. Very important. Q is 3 microcoulomb. 3 micro means 10 to the power of minus 6. Micro means 10 to the power of minus 6. R square. What is the distance? 10 centimeter. 10 centimeter means 10 into 10 to the power of minus 2. Remember this trick. This will be very helpful. You can directly convert centimeter to meter. Don't need to think anything about it. If it is given in meter, fine. you don't need to do anything. If it is given in centimeter, directly multiply with 10 to the power of minus 2. No need to write one extra step to convert. Or you should not be confused at 0.1, 0.2, 0.01 or 0.001. So that kind of confusion will not be there if you adapt this method of multiplying 10 to the power of minus 2 as soon as you see centimeter. Centimeter to meter means 10 to the power of minus 2. Okay. Now let's simplify. 3 9s are 27. 10 to the power of 9 into 10 to the power of minus 6, 10 to the power of 3 divided by 10 into 10 to the power of minus 2, that means 10 to the power of minus 1 to the power 2. So it will be 27 into 10 to the power of 3 divided by 10 to the power of minus 2. Okay, square part we have done at the last. Now 10 to the power of minus, when it goes up it becomes plus, so it will be 27 into 10 to the power of 5. 27 into 10 to the power of 5 Newton per Coulomb. Unit is very, very important. Now if you see that EB will also have the same magnitude. EB will also have the same magnitude. This is due to positive charge, this is due to negative charge. So direction will be different, but magnitude wise EA and EB are same. So EB will also have the same value, 27 into 10 to the power of 5, right? Yes. So EB and EA both are, see, it is plus 3, it is minus 3. So plus 3 and minus 3, the directions will be different, but magnitude wise they will be same, right? Because it only depends on the magnitude of Q, not on the direction. Direction of electric field will be different. In this case, in fact, the directions are also same, because one is positive away from, one is negative towards. Okay, the point of observation is very, very important. Point of observation is very, very important. So what is the net electric field? Net electric field will be EA plus EB. Why plus? Because both are in the same direction, that is 27 into 10 to the power of 5 plus 27 into 10 to the power of 5, that is 10 to the power of 5 is common. So 54 into 10 to the power of 5 Newton per Coulomb. The unit is very, very important. What is the direction? Direction is towards minus 3 microcoulomb. Direction is also important. It's a vector quantity. Electric field is a vector quantity, so direction is also very important. So you have to mention direction is towards minus 3 microcoulomb. Okay, so this is a small numerical question. Step is very simple and clean. Also calculations are not too difficult. If you follow the method, you can even, similar questions will come as a 5 marker question as well. There will be one more additional step to that. Okay, one more part to that question, but this type of question might come as a 5 marker question as well. They will add one more step, we will see that. Okay, they will add one more part B or part B. Okay, they will ask you to calculate one more thing, but this type of problem, if you solve this numerical also, you will get 3 marks in the long forms as well. Now derive the expression for the electric field at a point on the axis of an electric dipole. So here we have an electric dipole and we are trying to find the electric field on the axis. So suppose this is minus Q, this is plus Q. We are trying to find the electric field at some point, say P. Okay, now diagram is very, very important in this derivation. So the total distance is 2a and the distance from the center of the dipole is r. Okay, distance. Now why we measure the distance from the center of the dipole? Now I write r like this. Okay, if you are confused, if you see me writing like this, that means it is r. Sometimes I write properly, but sometimes in a hurry I might write it like this, so don't get confused. Okay sir, what is this? This is not gamma, this is simply r. Okay, right, clear? Now why do we take the distance from the center of the dipole? Because so there are two charges, so each of them will fight with each other. Measure the distance from me, measure the distance from me, like two siblings. If you have a brother or sister, you will know that whenever there is something new happening in the house, both of you are fighting. Okay, give this to me, give this to me, right? Similarly, they are two twin siblings, okay, and they are fighting with each other. Measure the distance from me. Then their parents came and said, no, neither from you nor from you, we will measure the distance from the middle. So this is called middle path, right? So that's why we measure the distance from center, so that no one get to feel depressed, and this is also easier. Now if this is the midpoint, what is this small distance? This small distance is A, and what is this small distance? This is also A, right? Now first we will find the electric field due to the individual charges, and then based on their direction either we will add them or we will subtract them, right? So now let us understand what is the direction of the electric field due to plus Q. Electric field due to plus Q, so this is plus charge, so electric field will always be away from plus charge. So electric field due to the plus charge will be away from. Okay, electric field due to the plus charge will always be away from. So what will be the electric field due to the negative charge? Electric field due to the negative charge is always towards it. So electric field due to the negative charge will be towards the charge. So this is the negative electric field. Okay, now you have to find their individual magnitude, E plus and E minus, and then you have to subtract them from bigger minus smaller, bigger minus smaller, that we have to calculate. Now how to do that? First we will see that what is the electric field due to the positive charge. Electric field due to the positive charge means we have to use our simple electric field formula, K Q by R square. Now in this case R plus square. Why R plus square I am writing? Because the distance from the plus charge to our point of observation is not this R. R is measured from the center. So what is the distance from the plus charge to this point? That is what is important. This distance is important, the distance between plus and the point. So if this distance is R, then what is this distance? That means R is basically have this extra A. So R minus A gives me the distance between the positive charge and the point. So E plus, we can write this as KQ by R minus A whole square. Simple. So what will be the electric field due to the negative charge? Now in this case negative charge is here, negative charge is here. So what is the distance between this and this? So this distance is R, and if you add A, if you add this extra A, you will get the distance from the negative charge to the point. So we can write this as KQ by R plus A whole square. Okay, now from these two equations it is clear that E plus is bigger than E minus, because denominator is smaller, its denominator is bigger. Now if you are not aware, if you are not able to recollect this, then you have to understand one more thing, that positive charge is closer to the point. This positive charge is closer to the point. That means electric field due to positive charge will be bigger compared to electric field due to the negative charge. Negative charge is slightly further from the point, right? So this plus is facing the point directly, this negative charge is coming after the positive charge, right? So electric field due to the positive charge is higher than the negative charge. So the net electric field we can calculate as E plus minus E minus. Why minus? Because they are in the opposite direction. If they are in the same direction, we can simply add them. Because they are in the opposite direction, you have to subtract them. So KQ by R minus A whole square divided by KQ R plus A whole square. Okay, so KQ you can take common and you will get r minus a into r plus a whole square, okay, and this will come over here, r plus a whole square minus r minus a whole square. Simple addition or subtraction of fractions, right? So now a plus b whole square minus a minus b whole square. So there is a formula that you have studied. If you forget that formula, then what you can do, you can just break them apart and calculate it. Otherwise, a plus b whole square minus a minus b whole square is a formula which translates to 4ab. So 4ab, okay, here a is r, b is a, so 4ra divided by, what is this, a minus b into a plus b, or a plus b into a minus b, that is a square minus b square. So here we get r square minus a square whole square. Okay, so this is the net electric field, but this is not over yet. You have to add one more not approximation, I will say one more small correction to this equation. What is that? That we know that a is very very small for a dipole. The distance between the charges in a dipole is very small, that is 2a. 2a is small means a will be smaller, right? So if 2 is, suppose 2a is 2 micrometer, then a will be 1 micrometer, right? So if 2a is small, a will be much smaller compared to the distance r. So r is greater than, very very greater than a. Why we are writing that? Because in the division we can see that there is a r square as well as 1 a square. So if this a square is very small, if this a square is very small, we can simply ignore this a square, and whatever r square is there, that will be the dominant force. Okay, so we will ignore this a square. We cannot ignore the a in the numerator because it is in the multiplier. So multiplication, whenever a small number is in the multiplication, we cannot ignore. If it is in the addition or subtraction, we can ignore that small number. So because it's a is small, a square will be much smaller. So that's why we can ignore this a square. So we can write the net electric field is KQ 4RA divided by r to the power 4. Okay, so r cancels, so you get this as KQ 4A divided by r cube. Right, now this is also not over. We have to do one more thing. What is that? K into 2 into q into 2a by r cube. What we have done? We have taken this q inside and divided this 4 into 2 into 2. So 1 2 we kept outside and another 2 we have kept with a. So 2a and 2 gives me 4a, so that is, there is no change here. So what we have done, we have just divided this. Now q into 2a, we know that charge into distance between the dipole charges, that means it is the dipole moment. So we can write this as k into 2p by r cube, and lastly you have to put the value of k, that is 1 by 4 pi epsilon naught 2p by r cube. Now vectorially the dipole moment is from negative to positive, the dipole moment is from negative to positive, and the net electric field is also in the direction of the positive, this direction. So vectorially this and this are in the same direction. So if you are smart, you will write this as in the vector form as well. So 1 by 4 pi epsilon naught 2p by r cube. This is the final derivation. Okay, clear? Any doubt, please mention in the comment below. I will try to address them in future. Now next, derive the expression for electric field at a point on the equatorial plane of a electric dipole. So now we will do the equatorial plane one. It is slightly complicated than the previous one, but again this is also very important. Equatorial plane means the plane which bisects the dipole into two halves. Okay, any point on this P, okay, any point on this P, no, don't take this point, take this point, this is our P. We will try to find the electric field on this point P. Now how to do that? Again the distance between the dipoles. So suppose this is my negative charge, this is positive charge, this is negative charge. Now we change the orientation for our simplicity, nothing else. Now this distance is A, this is also A, right? This distance is A, this is also A, and as I told you, we always measure the distance from the point, from the center. So this distance is R, this distance is R. Now what will be this distance then? This is important distance. Now this is equatorial plane. Equatorial plane means if you join these points, this will be an isosceles triangle. Isosceles triangle means this side is equals to this side. These two sides will be equal. Okay. Now this is R, this is A, this is a right angle, so this is an hypotenuse. So this will be R square plus A square square root. Similarly this will also be the same value R square plus A square square root. Both sides will have the same distance, but we will measure the distance as per our usual convention, that is from the center of the dipole, right? Now this is point P. Now how can we calculate the electric field? So first we have to calculate the electric field due to the positive charge. So electric field due to positive charge will be away from, same principle. Electric field due to the negative charge will be towards. So electric field due to the negative charge will be towards. Okay, so this is plus, this is minus. So the net electric field will be in this direction. The net electric field will be in this direction. Why? You can divide this into two components, one along y-axis, one along x-axis. Now y components due to the plus is in the upward direction, and y component due to minus is in the downward direction. So plus and minus, they will cancel, but the x component in both cases will be added. Now if this angle is theta, then this angle will also be theta. Now this is an isosceles triangle, so if this angle is theta means this angle will also be theta. If this angle is theta means this angle will also be theta. Alternate angle. Okay, in fact, because both the distances are same, okay, E plus and E minus magnitude wise, E plus and E minus magnitude wise will be same. Okay, whatever is the electric field, direction will be different. So E plus will be in this direction, E minus will be towards the negative charge, but magnitude wise they will be same because of the same distance, KQ by R square. That is the formula, simple formula. Q is same, K is a constant. So if R is same, the electric field has to be same, right? And we mention that common value as E, say. Okay, say. Say means imagine a unknown, right? So this is a way to write an unknown number. Anyway, now what will be the component of this vector in this direction? This is theta, this is E, both of them are E actually. This is theta, so the component will be E cos theta, right? E cos theta, adjacent to the theta. So any component adjacent to the angle is cos theta angle, right? This is E cos theta. Similarly, this is also a vector. Again, the angle is theta, so adjacent component will be E cos theta. So E cos theta plus E cos theta. So it will be 2E cos theta. Just understand this, it will be very simple. If you understand this concept, the remaining derivation is very easy. So the net electric field is basically 2E cos theta, as simple as that. Okay, now you have to put the value of E and cos theta and simplify. That's it. So what is the value of E? E is KQ by R square. Now here R square means square root of R square plus a square whole square cos theta, okay, or 2kq by r square plus a square. Now let me put the value of cos theta. So you consider this triangle, okay, so this is the perpendicular, this is the base, this is hypotenuse. So what is the value of cos theta? So again, cos theta is, some people have curly brown hair, base by hypotenuse. So base in this case, this is the angle theta, adjacent base is a by hypotenuse is square root of r square plus a square, okay, put that over here. So a by square root of r square plus a square. So we can write this as 2kqa divided by r square plus a square to the power 3 by 2. So this power is 1, this power is half, so 1 plus half is 3 by 2. Same value, right? X into x times x to the power of half. What is the value? X to the power of 3 by 2, right? Same thing we have done here. Now let us continue. So net electric field will be, now again we have to apply first let me put that 2kqa so that it is simplified. Q into 2a divided by r square plus a square to the power 3 by 2. Now Q into 2a, we already know that, we have done it in the previous derivation, that is, it is the dipole moment by r square plus a square to the power 3 by 2. Now for r very greater than a, obviously r will be greater than a, right? So if r is greater than a, then we can write this as net electric field is Kp divided by r square to the power 3 by 2. We ignored this a square, so Kp divided by r cube, okay, so these two cancel, so we are left with Kp by r cube. So this is the normal derivation, but we will not stop over here, we will write in vector form. So vector form, now value of k is 1 by 4 pi epsilon naught minus p vector by r cube. So why this is minus, let me explain that as well. So what is the direction of dipole moment? Dipole moment is from negative to positive. Dipole moment P is from negative to positive, okay, dipole moment is from negative to positive. What is the net electric field? Net electric field in from positive to negative direction, right? So the dipole moment is along the positive x-axis, and dipole moment is along the negative x-axis, electric field is along the positive x-axis. So they are in the opposite direction. That's why there is a negative sign. The negative sign will not come in the derivation, but negative sign will come when you put the vector sign, right? Clear? This is a smaller derivation, but the importance of the diagram is more here, because you have to understand that how you are writing this 2e cos theta. Now let's move on to the next question. Derive an expression for the electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss's law. So this question may accompany with the sub question that state Gauss's law and hence derive this. So that is also possible, but the derivation is easy. So here we have a very long, thin, uniformly charged wire. Again use scale so that you don't make a mess of it. This is charged, okay. Line charge density is lambda. Line charge density means if you take unit length of the wire, the charge on that unit length will be lambda. Okay, now what we have to do, we have to construct a Gaussian surface. Construct a Gaussian surface. Okay, a cylindrical Gaussian surface. Okay, cylindrical Gaussian surface of length L, small l, length small l. Now from Gauss law we know that first of all electric field will be symmetrical. Electric field will be symmetrical along the cylinder, right, along the surface of the cylinder. This is a three-dimensional figure. Okay, this is a three-dimensional cylinder, not a two-dimensional one. So electric field will be symmetrical. So from Gauss law, E dot ds equals to Q enclosed by epsilon naught. Now electric field is uniform. Uniform means the magnitude of electric field through on the surface of this cylinder is constant, right? So magnitude wise electric field is constant, so constant means it will come out of the integration, similar to that of the differentiation. When you do the differentiation of a constant, it comes out of the differentiation. Similarly for integration, if your integration is not yet done, you have to remember that integration also constants do come out of the integration. So EDS. Now what is the charge enclosed over here? That is very, very important. The line charge density is lambda. That means for unit length charge is lambda. Now what is the length of the cylinder? Length of the cylinder is L. So the charge enclosed will be lambda into L. Okay, charge enclosed will be lambda into L. The distance is R, obviously. The distance is R. Now what we have to do? So E into ds means surface area. Closed integral ds means total surface area. Okay, so what is the total surface area of the cylinder? Only curved surface we are considering, the top and bottom there is no electric field, so these two surfaces we will not consider. Okay, so what is the area of the curved surface of a cylinder? 2 pi RL. 2 pi RL, right? This is the area of a curved surface of the cylinder. That is equals to pi L lambda L divided by epsilon naught. Now L cancels, so from this we get E equals to lambda by 2 pi epsilon naught R. Okay, I generally prefer it to write this as 1 by 4 pi epsilon naught 2 lambda by R, so that this value comes as a constant. We know that this is a constant, but this is a good way to write. So electric field due to a uniformly charged line charge is 4 pi. This is the easy derivation, not long, neither difficult. Okay, easy derivation. Only thing, this may not come as a single derivation. They will ask state Gauss's law of electrostatics. So in that case the statement you have to write extra. Okay, otherwise this is a very simple and easy derivation. Now state Gauss's law in electrostatics, derive an expression for the electric field at a outside of a uniformly charged shell. Again statement we have already discussed, so statement I am not going to discuss over here. Again easy question. Here we have a charged shell and we have to only find the electric field outside. Inside it will be 0 anyway, so no need to do that. Shell means obviously thick cover. Uniformly charged plane, infinite plane, I have not seen in board exams. Okay, but for midterm it might come. So if you you can practice that, but I have not seen in many of the boards. If your midterm exam paper, if it is coming from the board, I have not seen that. Means your district midterm paper generally do not come. If your midterm paper is set up by your college, they might give you, but as I said, there will be alternative questions available to you, so you can skip that part. Okay. Now we are trying to find electric field at a distance say r from the center of the shell. So this is a distance r. So if this is the distance r, we have to construct a Gaussian surface, spherical Gaussian surface of r. Now again the same formula, E dot ds equals to q enclosed by epsilon naught. What is q enclosed? Q is the total charge on the spherical shell. Okay, so what is E dot ds? Again, E is spherically symmetric. Spherically symmetric means r distance is constant throughout the surface. So electric field magnitude wise is constant, so it will come out. So again ds equals to q by epsilon naught. Now what is ds? ds is the surface area of a sphere of radius r. So what is the formula for surface area of a sphere? Surface area of a sphere is 4 pi r square equals to q by epsilon naught. So E equals to 1 by 4 pi epsilon naught q by r square, as simple as that. Okay, so this is the derivation, simple. This is the easiest derivation, right? That's why if this question come, Gauss's law will definitely be asked. If this question does not come, then Gauss's law can be asked as a 2 marker or 3 marker question. But if this question comes as a 5 marker question, then definitely they will ask you Gauss's law. Inside anyway, if they add the also find the electric field inside. So in case of inside electric field, this is outside. Okay, for inside, okay, same formula, you will start the same way, but on the right hand side, or you will write 0 by epsilon naught, because there is no charge here. So charge enclosed over here is 0. So E will be definitely be 0. ds cannot be 0. Okay, ds cannot be 0. ds so if A into B is 0, okay, so either A is 0 or B is 0, right? We already know that, we have done this in algebra. But if it is given to you that B is not 0, B is not 0, then definitely A is 0. Then we can say that A is definitely 0. So now why I am saying that ds cannot be 0? ds is a surface area. So if this is your Gaussian surface, can the surface area be 0? Surface area cannot be 0. It has to have a real number, surface area. Surface area is impossible to be 0. Okay, so that's why ds cannot be 0. So only possible answer is E is 0. E dot ds means multiplication. So two numbers are multiplied. That's why E must be 0. Now time for us to solve numerical questions. 2 point charges plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in air. Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of resultant electric field at O if plus 4 nanocoulomb is replaced by another plus 8 nanocoulomb charge? So initially the first question is similar to that we have solved, only thing they have added one more part to that. Now let's see. So what is the charges? Charges are plus 4, so point A and point B, this is plus 4 nanocoulomb and this is plus 8 nanocoulomb. The distance between them is 0.2 meter. Right, and we are trying to find the electric field at the midpoint. Electric field at the midpoint. Right, so what again same method we will use. How to find the electric field? Both are positive charges. You see, both charges are positive. Previous case one was positive, one was negative. Here both charges are positive. So electric field due to this positive charge will be in this direction, so E4, and electric field due to this positive charge will be in this direction, E8. Now definitely who will be bigger? E8 will be bigger. Why? Distance is same. Midpoint means total distance is 0.2, that means this will be 0.1, this will be 0.1 as well. Midpoint means it has to be divided into two equal parts. So what is the electric field due to the positive 4 charge? So E4 will be KQ by R square, and E8 will be just twice of that. Easy to understand, right? So let us do that. So K is 9 into 10 to the power of 9, Q is 4 nanocoulomb, so 4 into 10 to the power of minus 9, nanocoulomb means minus 9. What is distance? Distance is 0.1, so 0.1 whole square. Okay, so it will be cancels, 4 9s are 36, divided by 0.1 means 10 to the power of minus 1 whole square. So it will be 36 into 10 to the power of 2. Minus 1 goes up, becomes plus 1, and there is a square as well, so square means 10 square. So it will be 3600. Okay, Newton per Coulomb. So what will be E8 then? E8 will be twice of that, so 2 into 3600. You don't need to do the calculation again, you know, because 8 is twice of that, that's why you can do that. If it is not twice, suppose this is given as 4 and this is 6, in that case you have to start from the same formula and calculate it. Okay, so it will be 7200 Newton per Coulomb. So what is the net electric field? Net electric field will be E8 minus E4. If you see that both are in the opposite direction, E8 and E4 are in the opposite direction, so E8 minus E4, so that is 7200 minus 3600, that is 3600 Newton per Coulomb. Okay, direction will be towards plus 4 nanocoulomb. Okay, always remember that electric field is always away from for positive, towards for negative. If you remember the direction theory, everything will be simplified. Now one more thing, what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is replaced by another 8 coulomb charge? So here we have plus 8, here we have another plus 8, so at the midpoint electric field, this will be plus 8, this will also be plus 8. So magnitude wise both the electric fields are same but in the opposite direction, this one in this direction, this one in this direction, so they will cancel each other. So net electric field, part B, net electric field will be 0. So this is part A answer, this is part A answer, this is part B answer. So net electric field will be 0. You can draw this diagram and simply write net electric field will be 0, or you can do the mathematics and show them it to be 0. I don't think the mathematics is required. If you draw the simple diagram, a teacher will understand that you have understood the question and you have answered it properly. So 3600 Newton per Coulomb and 0. Also important to note that the unit is very important to write. If you don't write the unit, marks will be deducted. Unit is must. 2 point charges plus 5 microcoulomb and minus 5 microcoulomb are located at A and B, separated by a distance 0.2 meter in vacuum. So it is similar to that 3 microcoulomb question, right? What is the electric field at the midpoint O of the line joining the two charges? If a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? So here we have, let me draw the diagram over here. Here we have plus 5 microcoulomb and minus 5 microcoulomb. Midpoint P, we are trying to find the magnitude. So what is the distance? Distance is 0.2 meter. So this is 0.1, this is 0.1. Now electric field due to the positive charge is this direction, electric field due to the negative charge is in this direction. Both are in the same direction. Why? Because electric field due to positive is away from, electric field due to negative is towards. So plus means away, negative means towards. Okay, so what is the electric field due to positive? In fact, positive and negative magnitude wise both will be same, right? Distance is same, magnitude is same, so electric field magnitude will be same, which is given by kq by r square. So what is k? K is 9 into 10 to the power of 9. Q is 5 microcoulomb, so 5 into 10 to the power of minus 6, and distance is 0.1 whole square. So 5 9s are 45 into 10 to the power of 3 divided by 10 to the power of minus 2. Okay, 0.1 means 10 to the power of minus 1, minus 1 square minus 2. So it will be, so E net, so this value will be 45 into 10 to the power of 5 Newton per Coulomb. So net electric field is basically sum of these two electric fields. Right, so it will be 45 into 10 to the power of 5 plus 45 into 10 to the power of 5, both are same, right? So it will be 90 into 10 to the power of 5 Newton per Coulomb, or you can write 9 into 10 to the power of 6 Newton per Coulomb. Okay, so this is the net electric field. If a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force? So this is part A. This is part A. Now what is the part B? Part B is, we know that force is basically Q into E. Force is basically Q into E. So what is Q? Q is 2 nanocoulomb, 2 into 10 to the power of minus 9, and the electric field we have calculated 9 into 10 to the power of 6. So it will be 18 into 10 to the power of minus 3 Newton. 18, 2 9s are 18, 18 into 10 to the power of minus 3 Newton. So the electric field is 9 into 10 to the power of 6 nanocoulomb. Okay, this is one answer and this is one answer. Try to underline the answer so that teachers don't need to wait too long or read too long. You can find the answer quickly. 3 charges each equal to plus 4 nanocoulomb are placed at the 3 corners of a square of side 2 centimeter. Find the electric field at the 4th corner. So another interesting question, very common in midterm exam. So here we have a square. Square means all sides are same. Okay. Sides are given as 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. Now in 3 corners we have charges. Okay, so here we have charge plus 4, here we have charge, here also we have charge. We are trying to find the net electric field here. Okay, how to do that? So first, what are all the charges? 1, 2, 3 charges. The distance for this charge is this, distance for this charge is this, distance for this charge is this. Now here, this is not simply finding the electric field and adding them. This is a vector quantity, so addition has to be done in vectorially. That is why this question is slightly tricky. Okay, this question is slightly tricky. Let me redraw this so that I get enough space to draw the vectors. So let me draw them here. So in this case the main problem is the vector addition. Calculating the individual electric field, I hope you can do that by now. And this distance is easy. Okay, if all the sides are A, then the corner is given by A root 2. Corner or diagonal is given by A root 2. If all sides are A for a square, then the diagonal is given by A root 2. Right? Now in this case A is given by 2 centimeter. So diagonal is 2 root 2 centimeter. Again to convert centimeter to meter, we will use our regular trick, multiply by 10 to the power of minus 2. Now this is a plus charge, so the electric field will be in this direction. This is also a plus charge, so this will be in this direction. In fact, both are in the magnitude wise, both will be in same direction. Okay, so if this is electric field, say E, this will also be E. Now what is the resultant of these two electric field? The resultant of these two electric field will be E root 2. Okay, if sides of our right angle triangle both are A, then this becomes A root 2. So basically, if this is a vector, this is a vector, their addition will be A root 2. That is the basic triangle law of addition. That's why we can say that because both the vectors are magnitude wise same, if you see that the values are same, it will always be given like this. Remember that the values of these two charges will always be same, otherwise it will be very complicated question to solve. Okay, and this one is already in this particular direction. So E1, E2 are same. Only thing that we have to calculate is the electric field due to this and add with them. Let me call that as E3. So this is 1, 2, 3, like that. Okay, so this is the main thing that you have to remember. Either understand it or remember it, whatever way you are comfortable. Okay, so electric field due to this plus 4 is constant. This will be the same value. Why? The distance is same. This is also A, this is also A. This electric field is, by the way, is not same because its magnet distance is different. So electric field due to this is, say, E. Electric field due to this will also be E. Okay, and because they are perpendicular, their magnitude will be, the resultant of the magnitude will be E root 2, and that will be exactly along the diagonal. Right, now along the diagonal the electric field is again along the diagonal, so these two vectors are in the same direction, so you can now add them. Okay, so first we will find the electric field E. What is E? KQ by A square. KQ by A square. So what is K? K is 9 into 10 to the power of 9. Q is 4 nanocoulomb and A is 2 centimeter, that is 2 into 10 to the power of minus 2 whole square. Okay, this is the formula for electric field. So it will be 36 divided by 4 into 10 to the power of minus 4. 4 into 10 to the power of minus 4, so it will be 9. So 9 into 10 to the power of 4. 9 into 10 to the power of 4 Newton per Coulomb. So this is electric field E. Now this is, we are saying this, both of them will be same. So if you calculate once, done. Now what is the electric field E3? Electric field E3, this is 0.1, 0.2, this is 0.3, this is 0.4. Okay. Okay, so that's why I am saying this is electric field 3. So that will be KQ by A root 2 whole square. That will be 9 into 10 to the power of 9. Q is given by 4 into 10 to the power of minus 9, and A is 2 into A root 2 is 2 into root 2. So it will be 2 root 2 into 10 to the power of minus 2 whole square. Now simplify. 10 to the power of 9 minus 9 cancels. So we get this as 9 into 4 divided by, this will be 4 into 2, that is 8, into 10 to the power of minus 4. So it will be 2. So it will be 4.5 into 10 to the power of plus 4. 4.5, 9 divided by 2 is 4.5. So 4.5 divided by 10 into 10 to the power of 4. So now what is the net electric field, by the way? Net electric field I already explained, that will be E root 2 plus E3. Okay, why E root 2? Because there are two electric fields, they are perpendicular to each other, so their net resultant is E root 2, which is in the same direction as E3. So same direction means we can add them. Same direction means we can add them. So it will be 9 root 2 into 10 to the power of 4 plus 4.5 into 10 to the power of 4, which will be 9 root 2 plus 4.5 into 10 to the power of 4 Newton per Coulomb. Now if you put that value in the calculator, you will get this value as 17.22 into 10 to the power of 4. So this will be coming out to be 17.22 into 10 to the power of 4 Newton per Coulomb. Okay, you need to use the calculator. Okay, once you use the calculator, and you can calculate this answer. This is very interesting and important question. Now next question, a conducting sphere of radius 10 centimeter has an unknown charge. So conducting sphere of radius 10 centimeter has an unknown charge. Charge is not known. If the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power of 3 Newton per Coulomb and points radially inward, what is the net charge on the sphere? So electric field at a point 20 centimeter is given by this magnitude and it points radially inward. Radially inward means it points towards the center of the sphere. That means obviously it is a negative charge. Q is negative. That's it. So what is the formula? Gauss's law, E dot ds equals to Q enclosed by epsilon naught, or E equals to 1 by 4 pi epsilon naught. The derivation we have just done, so I am just writing it, Q enclosed by epsilon by r square. Derivation is the same as the spherical shell. Okay, so electric field will be 1 by 4 pi epsilon naught Q by r square. Okay, so this is the shell of 10 centimeter and this is the point where we are measuring. This is 20 centimeter. Now radially inward means, electric field is radially inward means the charge must be negative. The charge must be negative. Okay, what is the value? 1.5 into 10 to the power of 3 equals to, now what is 1 by 4 pi epsilon naught? 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 into minus q divided by r square. What is r? R is distance. So distance is 20 centimeter over here. So 20 centimeter means 20 into 10 to the power of minus 2 whole square. Now simplify. So minus q will be equals to 1.5 into 10 to the power of 3 into this. Okay, so 20 square means 400, 10 to the power of minus 4 divided by 9 into 10 to the power of 9. Okay, now let's simplify. Six by 9 into 1.5 into 4 is 6. Okay, you can use calculator, but I don't like to use calculator. So 1.5 into 4 is 6, so that's why 6. So 2 zeros, minus 2 plus 1, and it goes up, so it will be minus 10, no, minus 8. Okay, so it will be 2 by 3 into 10 to the power of minus 8, or 0.66 into 10 to the power of minus 8, or 6.67 nano coulomb. 6.67 nano coulomb. Not only that, Q will be minus 6.67 nanocoulomb. You can use simple basic calculator and calculate it. 2 by 3 means 0.666 or 0.667. Okay, so it will be 6.67 nanocoulomb, and it will be negative. It will be negative because the electric field is radially inward. Okay, so don't miss the negative sign. A polythene piece rubbed with wool is found to have a negative charge of 3.2 into 10 to the power of minus 7 coulomb. Estimate the number of electrons transferred. So the charge is given here as 3.2 into 10 to the power of minus 7 coulomb. So what is the number of electrons? We know that charge can be written as n into E, where n is an integer, that is number of electrons, and E is charge of each electron, that must be equals to 3.2 into 10 to the power of minus 7. So n must be 3.2 into 10 to the power of minus 7 divided by 1.6 into 10 to the power of minus 19. So it will be 2 into 10 to the power of 12. This is the number of electrons which is transferred. Now, is there a from which to which? So you also have to mention from which to which. Now for that, electron affinity chart, if you remember, electron affinity chart, it mentioned that electrons are transferred from wool to polythene. So it will be transferred from wool to polythene. So from wool to polythene, the electrons are transferred. Is there is a transfer of mass from wool to polythene? So see, in the option B, the question itself mentioned from where to where the mass is transferred. So electrons are transferred from wool to polythene. Is there is a transfer of mass? Now mass of an electron is very small, 10 to the power of minus 31. So transfer of mass, this is part A, both. Okay, part B is negligible. Transfer of mass is negligible because mass of electron is very small. Even though there is a mass transfer happens, but that transfer is negligible due to the very low mass of the electron. Okay, so from wool to polythene, the electrons are transferred and the mass transfer is negligible. Right, so this is the last question from this chapter that we have discussed. Okay, I will be back with the new chapter in our upcoming days. Till then, bye, but don't forget to revise the entire chapter, theory, MCQs, as well as these 2-3 marker questions. And if you have any doubts, don't forget to mention in our comment below. Also, don't forget to join our WhatsApp channel and give it a thumbs up if you like this video. I will be back. Till then, bye.